not sent to you.
No, it
Anyways,
wasn't.
anyways. So Rayyan, in last class, you said that in your school you are
Mm,
being taught or you were asked questions regarding oscillation.
yes.
All right. So, so currently in your school, which chapter is being taught?
Uh, 1 second. I'll check. Um, we're doing forces right now.
You are studying forces right now.
Yeah,
All right.
fundamental forces.
Fundamental forces. Okay. Uh, Yesterday, you told in the previous class, you told me about the curriculum or the book you were following. Can you please repeat the book name? Uh,
Yeah, MYP.
it was MYP
Yeah, MYP physics year 4 and 5
physics
by concept.
by concepts. All right, all right, all right. So it's been only a week or two since your class has started, no?
Yeah.
All right. So can you list the names of the chapters in physics in your syllabus?
We didn't get a syllabus, but
You haven't got the syllabus yet.
yeah, no, because we just start new topics and then they get posted onto Total, and then we find like our presentations and stuff from there, and then we study from there.
Okay. All right. I'm asking this because if we are going to study in a
Mm,
structured manner, you need to know the syllabus very well. You need to know what are the topics that are going to be taught to you in the class. All right. You see, in IB board, that is International Baccalaureate Board, has a different approach towards study, and they have got different syllabus. All right. So you have been studying in this board. You joined this International Baccalaureate Board few years ago only.
yeah.
All right. So it has got a different structure. It has got it has a different approach towards the study. So that's why I'm asking you about the syllabus. What are the topics? What are the chapters you are going to study? So
Mm,
according to that only, I will prepare you. You see. All right. So right now you are being taught about forces.
yeah.
All right. So far, what are the things you have studied in force?
We just learned about like oh, we learned what is a force, what are its units, and fundamental forces like gravitational,
The
electromagnetic,
electromagnetic.
strong nuclear, and weak nuclear. Um,
All right. All right. So were you able to solve that oscillation problem?
yeah, it was like a lab report and I already finished.
You finished that. All right.
Mm,
All right. So your concept regarding pendulum is clear.
yeah,
You know about the frequency, the different concepts, what that applies in the working of a pendulum.
kind of, yeah.
You know it a little bit, or you have a general idea of
Yeah.
how it works. All right. If I were to ask, what is the relationship between frequency and time period of a pendulum? What would you say?
Uh, I would not know because we didn't dive too deep, like
Okay.
because we only did like the experiment and then we had to write a lab report on it, and we didn't like do too much on the actual experiment. We spent
All
more
right.
time on the lab report.
All right. So, what's the approach of the teacher and doing experiment? Like they just give you a formula that this is the formula to calculate time period. These are the values, and you just have to do this. Or
Yeah, no, so they gave us like obviously the clamp, the pendulum, and
obviously
the string, and then we had to count 15 oscillations at different string lengths.
at different
Yeah.
string lengths,
Yes,
and
and we
then
had to record the time taken for 15 oscillations
all right.
and then divided by 15, I think.
No, that's not how you do.
I don't,
You must have come to a conclusion. At the end of the experiment, you must have established a relation between the frequency and time period, or you can say the time period and length of the string. It was basically
yeah,
relationship between time period and length of the string. So
yes.
what was this relation that you established?
Like, what do you mean?
Yeah,
Like, what do you mean the relation?
I mean that there's a relationship between, I mean to say, the length of the string of the bob, or say the pendulum, determines the time period.
Yeah.
You see. So
So,
what was the relationship between the two?
I think like it decreased, the time decreased when the string got shorter. Like to get 15 oscillations, the time was decreasing.
Mm, no, you see what happens. You must have come to the conclusion that this must have been your experiment. Let me draw it afresh. Let's say you took different measurement of this string. All right.
Mm.
Let's say this was the length. All right. And let's say this was the time for oscillation. Let's say that we are considering how many oscillations. Let's consider 20 oscillations. All right.
Mm.
And mm, let's consider time period. You know what is time period in context of pendulum?
No.
Time period is nothing but the time taken to complete one oscillation.
Oh, yeah. Okay.
It is nothing but the time taken to complete one oscillation.
Mm.
All right. You must be aware about terms like frequency.
Yeah.
So how do we calculate time period?
Uh,
Small t upon, in this case, it will be 20.
20.
All right.
Mm.
This is length of the string. This is the time period. This time period. This is capital T. You must have taken, let's say that you must have taken the value, let's say 25, or in first case, let's say for the length of the string 25, the time period taken was, let's say it was around, I mean, let's say 20 seconds. What will be the time period here?
Uh,
How did you calculate the time period?
20, 20 over 20.
20 over 20, exactly. That is one. In another case, you must have taken, or let's take a strength of length 36, or let's in this case consider the time taken for 20 oscillation 24 seconds. What will be
Mm.
time period here? It will be
24 over
24 upon 20.
4. Oh.
That will give
Mm.
1.2. All right. Let's say that in the next case you took 49, or let's say, mm, let's consider in this case 28 seconds. All right. What will be the time period? 28 upon 20, that is 1 point what?
Uh,
1 point?
3.
No, it will be 1.4.
Oh,
It will be 1.4. So what exactly we are trying to do here is trying to establish a relationship between length of the string and time period. You see, what was the length of the string here? In the first case, it was 25. And what was the time
Mm.
period? 1 second.
Oh, yeah.
Okay, it isn't second. It was 1 second. And we square this value, we will get 25. Let's say in the second case, what was the length? 36.
Mm.
It was 36. And what was the time period?
1.2.
1.2. And this will give us again value of what? 36
36.
4 4. It will give us 25. And
Mm.
again, when you will do this third calculation, you will get the value 25. So what
Mm.
you can observe here, that length is directly proportional to square of time period. How? You see, if you were to square this value,
Yeah.
if you were to square this value, you will simply get what? What will you get?
1.
You will get 1. And here's the length.
Mm.
The basic thing is, let's say that where was I? Uh, can you repeat what we were discussing?
The square.
You see, this is the length of the string. This is the
Yeah.
time period.
Yeah.
All right. We established a relationship here. That relationship will give you. Let's say this is 1. That is t square proportion 12. That was 1 square. That was proportion 25. And plus. Yeah, sorry about that. Yeah. We were actually trying to establish a relationship between length and the time period. So after this, what was your approach? What did you get? We are seeing that we are getting the same value of what is 25, 25, and 25.
Mm.
What did you did after? You must have taken some another value. I took some another value.
uh, Time taken for oscillation.
That no, that's not what we are doing here. We are actually doing here that for different length of the string, the time period will act differently.
Mm.
Right. If the length of the string is shorter, time period will be larger. And
Okay.
if the time period and vice versa, you can see that. So you see here the length is 25 and time period is t square. If you establish a relationship, if you solve this, you will get 25. Again, in the second case, here the length was 36. Here the length was 36, and the time period was 1.2. You square it, and you are getting the same value. You see, are you getting it, or there's some sort of confusion?
Yeah, little I'm getting.
I think let it be. I mean, you need to study the whole chapter to get the better clarity of this concept. I mean,
Mm.
we have just did a little experiment and might get confusing for you. All right. So, what do you understand by force? What do you understand by force?
Yeah, sorry. Hello.
Yeah. What do you understand by force?
It's like a push or pull or uh, like something that acts upon an object.
It acts upon an object. All right. Force, in your class, a very basic definition is being taught that a force is kind of a push or pull. Either you are pulling an object towards you, or either you are pulling that object away from you or towards
Mm,
something. All right. So these are simply these are the two types of force. All right. A force may lead to change in the either it will lead to change in the shape of the object, or either it will lead to change in the position of that object if the object is placed at certain position, and if you are applying from force from here. All right, if this applied force is stronger than this frictional force. You studied about frictional force.
mm, mm.
What is it?
Like when two forces act upon each other and think it creates power between, so it either slow something or make it faster.
No, that's a different thing. There's no concept of power here. You see, frictional force is an opposing force. It is an opposing force.
Mm,
It opposes the change in its position. You see, for example, if I'm applying a force of 10 Newton from here, all right, but this frictional force is applying a frictional force, a force of 15 Newton. 15 Newton just opposite the direction towards which I am applying force. Then will the
mm.
object move?
Uh,
I'm
it'll move.
applying a force of 10 Newton on this object.
Mm,
All right, let's say this is a wooden box. Okay. And it is in contact with ground or some table. Let's say this is a table. All right. And it is applying frictional force. Frictional force is working here.
mm,
And that frictional force has a value of 15 Newton. Will the
mm.
object move?
No.
No, certainly not. To move that object, I need to apply a force bigger than 15 Newton. Got it? Apart from these two forces, there acts a third kind of force on this object as well. You see, that is the force of gravity, which we represent as small g. The force by which Earth attracts objects towards its core. Getting it?
Yeah.
So G is equal to 9 point. That is acceleration due to gravity. That is 9.8 meter per second square. You see? So in force, what else were taught to you in what else was taught to you in today's class?
The gravitational and electromagnetic. mm,
What do you understand by gravitation?
mm, like what? Like the power of gravity is like it's so gravity helps something come down or go up, but
You see,
pushes down.
every object in the universe is attracting each other with a force. That is called gravitational force.
Mm,
All right. And there's a constant between every two objects that we call gravitational constant, and that we represent as capital G. All right. No matter how small or the big object is, every object is applying force towards each other.
mm,
All right. You see, even if it were to be an atom, and even if it were to be a planet, there will be a certain force acting between these two bodies. You see, and that is called gravitational force. All right.
Yeah.
And the thing is that the bigger the, the body having the higher mass attracts the body having less mass towards it. Getting it?
Mm. Yeah.
What else did you study?
That's all we did.
That's all you did today.
Yeah.
All right. So, so Rayyan, talking of syllabus, currently you are being taught forces.
Yes.
All right. So, has the teacher told you about the further chapters which are going to be discussed in the class?
No, he hasn't.
All right. Can you share the content of the book which you are following?
We don't use the book, but we have like some PowerPoint that I could share with
All right. You have got PPT.
you. Yeah.
All right. You must be having some content or some syllabus.
Yeah, it's all on the PPT.
Okay. Okay. Do one thing. Share this to me. All right.
Okay.
Only the content portion. All right. Okay. So that I will have an idea of what are the chapters that has to be taught to you. All right. Because right now I don't have a very clear uh, picture about all the chapters which you are going to be taught. I don't know the name of the chapters. All right.
Yeah. There's an introduction sheet, but it's only for this chapter.
All
There's
right.
no other thing for any other chapters.
All right. All right. So, have you heard of the second pendulum?
Oh no.
You haven't heard about the second pendulum or other kind of pendulums like compound pendulum?
No.
No, you haven't. All right. Hello. Hello, Rayyan. Are you still there?
Yeah.
Yeah. Sorry. Yeah, sorry about that. Uh, you see, Rayyan, IB boards have no different in different IB board schools. You are having different syllabus. You see, all the schools are following. There's a difference in the patterns which are being followed in different schools. So you
Yeah.
see, what you have to do, you send me the picture of the content of the book or the PPT which you were referring to earlier. All right,
Okay.
all right. So you do this thing, and I have got few questions for you. All right. Are you able to see the screen? Are you
I
able
can
to see the
see. I
question? Is
can
it visible?
see. No, I can see where it says forces and stuff.
Is the screen visible to you? There are
Yeah.
two questions.
No, there's no question.
Just a minute. Yeah. Is it visible now?
Yeah, I can see it.
All right. Read the first question.
Okay. In 2008 Olympics, Jamaican sprinter Usain Bolt shocked the world as he ran the 100-meter dash in 9.69 seconds. Determine Usain's average speed for the race.
All right. The question seems pretty simple. Solve this question. You have got somewhere around 4 minutes. All right.
Sir, will it be 100 plus 9.69 divided by 2?
No, both the values are of different parameters. You see, one is a distance and the other is time. You can't
Oh,
add two values
hmm.
having different unit together. See, you have to calculate the average speed during his race.
That's all right. Don't know how to solve this question.
You aren't able to solve the question.
Yeah.
You see, the question is pretty simple. You see, in 2008, Usain Bolt made a new world record. What he did, he ran a distance of 100 meter in just 9.69 seconds. All right.
Hmm.
So the question is very straightforwardly asking you that what was the average distance of Usain Bolt in covering this distance? You see, this was a 100-meter track, and he took 9.69 seconds to cover this distance. Now, in the previous in the previous question, in the previous class, I told you about how to calculate the average speed of a body or a human being. You see,
Hmm.
you just add the total distance and divide it by total time taken. What is the total distance taken by, what is the total distance run by Usain Bolt here? The distance here is
100.
100 meter. And the time taken?
9.69 seconds.
9.69 second. You see, meter and second, these are the standard values for calculation. So we don't have to convert the value. All right. So we simply divide this. What will you get? What will be your answer?
Uh,
Divide this value. We will divide it by
uh, 1.
do this calculation.
Okay.
You see, this value will be around 9.3. All right. So this
Yeah.
was the average speed of Usain Bolt while he was running 100 meter. You see, any confusions?
No.
All right. And make sure that when you are adding two quantities, they must be of same entity. They must be having same unit. You can't add a value. You can't add two values having different units.
Okay.
All right. I've got one more question for you. Solve this one. The second question. The time period of a simple pendulum is 2 seconds, find its frequency. Yes, Rayyan. Are you done solving the question?
I couldn't solve.
All right. See, Rayyan, moments ago I told you how to solve, how to calculate the time period of a pendulum.
Hmm.
You see, to solve this question, you see, time period, you must have, you must be knowing this formula. Time equals to pi. Or have you done this formula? Or while doing experiment in the in laboratory, were you being taught this formula? If not, then we won't continue this.
Which formula?
Were you told about this formula?
Yes, but the
Yes.
data that I was given was from a friend because I was absent on the day. So I didn't use the actual formula.
Okay.
But I think we've covered it in class.
You have
We
this
talked
was
about it.
covered in your teacher talked about this formula in the class, but you were
Yeah,
absent
like we
that day.
started. Yeah.
All right, okay. So Rayyan, this was all about the basics, and I wanted to know about